Okay, part B. Part B says, find the second derivative of B. We have the first derivative of B. To find the second, we have to take another derivative. So that's what I'm showing right here. Taking a derivative of dB dt. Everything's in terms of time now, so it's over dt. That means you're taking d over d, that should be a t, sorry, d over dt of dB dt. The 1/5 is a multiplying constant. The derivative of 100 alone would be 0. And then you'd have the derivative of b, which is dB dt. But you can't stop there or you get no points. Because they said in terms of b, this is the second derivative of b in terms of the first derivative. So you've got to plug in for dB dt the first derivative. So my final answer has to be 1/5 times negative the first derivative, like that. Don't need those extra parentheses. That's 1 point. Use this thing to explain why the graph of B right here cannot resemble, the actual graph of B cannot resemble this graph. So here's the idea. They show us the bird's weight's going to go from 20 to 100. We have this formula here for calculating the second derivative of B. But this formula, if B never goes above 100, this will always be positive. Multiplied by this negative would make it negative. Multiplied by the 1/5 out front would still be negative. So we've discovered that for all weights of the bird from 20 to 100, the second derivative of B is always a negative number. Therefore, the graph of B itself must always be concave down. However, this graph has a concave up section. So the actual graph of B must always be concave down. 1 point for the explanation, 1 point for correctly finding the formula for the second derivative of B. As far as the explanation, key things you've got to point out to the grader is you understand that since B will never exceed 100, the second derivative of B, you don't have to write the formula again. The second derivative of B is always going to be negative. So if the second derivative of B is always negative, B is always concave down. The graph they gave us is not concave down, always. So you need some explanation like that to get that point.